Okay.
Crawford, let me ask you questions.
There's what?
No, you can hear us, Crawford.
You're on YouTube right now.
Hey.
You like to hear yourself, huh? Okay, here we go. So here's the deal. I'll give you the test back as soon as I'm done. Last period they had 15, 20 minutes to work, so I'm assuming you'll get about the same. You were supposed to have picked this up, problem 12. The reason I did this for you is because it says copy the parent function down 7 times and then do the following transformation. Well, it's no fun to copy it down 7 times. So I did it. You translate it right, left, up, down, do all that. Did you not get this yesterday?
No.
Who did not? There's one, there's 2. Okay, there's 1. Okay. And you 2 did not? Everybody get one? Carly, you did? Okay. Alright. There you go. Okay. Okay, now, do you remember 2 days, no, maybe Monday this week I said, here are the parent graphs of the most basic functions we have in algebra, and they are like the square root function, the squaring function, quadratic, absolute value, cubic, there's a whole bunch of them. You remember that?
Yeah.
You're supposed to know them. Now on your test, the last 3 questions were pretty much the same, I think. It was this, then there was this, and then there was another one.
X squared.
Oh, just x squared, yeah. Now, you guys, you pretty much got full credit for all this, but some of you just got a little sloppy. Like, for instance, if you are going to graph the parent, and you need to know this, when you put 0 into this function, what do you get?
0,
1.
1,
2 goes in.
4.
Okay, so it's 0, 1, 1, 2, 4. And then, of course, you mirror it because it's symmetrical to the y-axis, so you should have done this, right? But on the test, it's like some of you did this. You did this point, you did this point, this point, this point, and then maybe all of a sudden here you just went like this. That's a little sloppy, right? Kind of sloppy. So I probably circled this one on you and took off half a point. You can't be sloppy. You've got to know your parents. Your parent is going to do the same thing every time, and you're going to today move it right, left, up, down, reflect it, stretch it, compress it. You're going to do all the things you did last year, okay? But if you don't know your parent, you're not going to know what to do. So what's this one do?
It's a V.
Yeah, but 0 goes in.
0,
1 goes in.
1,
2.
2.
Okay, so it is. It's just a V. Whatever the x is, the y is the same. But when you jump over here, -1 goes in.
1.
Back up, yeah. Okay, so there you go. And you got to know what it does. This one, a square root function, a little sloppy, some of you. 0 goes in,
0.
0 comes up. Now if you put it, what's the next good number to put in?
9.
1.
You know the square root of 1, don't you? 1 gets what?
1.
1. Next good number.
4.
Okay, 2, 3, 4. 4 gets what?
2.
2. Next good number.
9.
6, 7, 8, 9. 9 gets
3.
3. And it kind of does one of those, right? That's the parent on all 3 of those. There are more functions. I'm not going to go over all of them. You were supposed to study them last Monday. Look at them, be close, okay? So here's what you're going to do today. Today you're going to, let's go here. Okay, students can graph functions by hand using the 6 transformations. Right, left, up, down, symmetry, and stretches and compressions, okay? So you need to know how to do all those, okay? Students can write an equation just by looking at a function on graph. This is kind of hard for students to do, but we'll get into it, okay? So here we go, but before we start, I'm going to go through this kind of quick. I just want you to watch this. Don't write anything down unless you feel like you have to. Okay, so this is your parents, okay? You and I just did this. 0, 0, 1, 1, 2, 2. -1, 1, -2, 2. So it kind of goes like this, right? Okay, there you go. Now, here's what's happening to you today. Today you're going to take your parent, you're going to get a brand new function called g of x, and it's going to be your parent, but it's going to be transformed. So you're going to take your parent, let's do this one. That's your parent, and let's add 3. Do you know what that does?
Shifts it up 3. Up.
Is it up 3 or down 3, or is it right 3 or left?
Up
Oh,
3.
You guys all agree it's up?
Yeah.
Okay. You just put a 0 in, just check it out. What's the absolute value of 0?
0.
0 goes in, what would come out?
3.
3. So yes, this is up 3. This is a shift, and we call it a vertical shift up 3. Okay? So if that's up 3, what's down 3?
Minus 3.
Okay, so you could get a minus, and a minus would be down 3. Does that make sense? So your graph would be right there at 3. It would do the same exact thing. Now, you don't need to sit there and go, oh, this point is going to go up 3. This point, up 3. If you know the pattern. The pattern is what?
Right 1 up 1.
Right 2, up 2. So couldn't you just do this? Right 1, up 1, right 2, up 2. Okay, and then left 1, up 1, left 2, up 2, right? Couldn't you just do that? Or you could graph your parent, like I did, and then just go like this, up 3. Oh, I said up 2, didn't I?
Okay.
3.
Oh, no, I'm sorry. I got kind of blanked out on what I was doing there. Okay, so there it is, and there it is. Okay, it works. You can draw that parent every time, and just raise it 3 or drop it 3, okay? So let's do this. What makes it go right and left?
If it's in
Minus.
Inside parentheses
Grouping
or
symbols.
grouping symbols. These absolute value bars, they are grouping symbols. So if I did, well, let's not use G. If I did h of x equals that,
Right 2.
is that right 2 or left 2?
Right 2.
Right 2, okay. Well, if you're saying right 2, then, okay, if I want that vertex right there, you say push it right 2. Okay? Well, then this number would have to be 2 goes in, what do you get?
0.
0, absolute value of 0, 0. So, did we do it right? Yeah, we did. So when you look inside there, guys, if you look inside and see x minus 2, it seems minus 2 is backwards 2, but it's the opposite of what you think. You're going which way? You're going to go forward 2. So this is a what shift?
Right.
Well, it's called a
Horizontal.
horizontal shift. What direction? Right 2. Okay. So that's what that is. Okay. And then of course from this point, which is your vertex right there, guys. Okay. You just go right 1, oops, to 3, and then go where?
Up 1.
Up 1. Right 2. Up what? 2. Go like this, and of course left 1 up 1, left 2 up 2, because you know what your parent looks like. Now, did this graph change in shape?
No.
No, it's the same shape. Okay, it did not get skinnier or wider. It didn't do that, did it?
No.
Okay, so that's these kind of transformations. The shape never changes. All right. When does the shape change? Hang on, I'm getting ahead of myself. Sorry. Let's do this. Let's do something like this. Here's f of x. Okay, that's the parent. What's this going to do right here? 1 second. I want to change it to g of x. Okay. You're going over here. Check the calendar. Number 12. You can just do it on that worksheet here. Okay. Okay. So what's this going to do, guys, to the parent?
Okay.
Reflected over the x.
And the outside of
Is that a reflect over the x, or is that a reflect over the y?
X. Because it goes over the y, it's the same.
It's not outside.
Okay, let's think about it. You guys tested for symmetry, right? When you tested for, listen, when you test for the y symmetry, what did you switch? you switch the x. When you were testing, is it symmetrical to the y-axis? I switched the x. Isn't that x, hasn't that been switched?
Yeah.
This one is symmetrical to what? Okay, and I'm sorry, we don't call it symmetrical. We call this what now? It's a reflection
Stayed the same.
over what? Y-axis. Okay. Whoops. Okay, so if I go like this, and I go, here's my function, right here, okay, right here. That's absolute value of x. The only weird thing about this is when you reflect it over y, this point gets reflected over here, and this point gets reflected over here. So does it look any different?
No.
No, that's a weird one. You did reflect it, it just didn't. It doesn't look like it's anything new. It's the same graph as the parent. Okay, so what's it going to look like when I reflect it over the x-axis?
Negative on the outside of the group inside.
It's going to be, the negative goes where?
Outside of the group.
On the outside. Now, do you remember this? When you reflect over the x-axis, you switch the what? Y. And here's what happened. You switch the y, that's y by the way, then you divide the y by -1, and then you divide that function by -1, and this is why you get negative there. So that's, okay, that is why the negative is in front, because you really put it in front of h of x, then you divide it by -1, and you got negative in front of your function. So if you did this one, it would look like this. Here's your function, right? That's the parent, right? But when you reflect it over, what am I reflecting over?
X-axis.
Over x-axis. Now, this point, which might be 3, 3, becomes what?
-3, or no, +3, -3.
Yeah, now it becomes right here, 3, -3. Just like that. Well, I should go a different color on you. Okay, let's go that way, and then it's going to go that way. Right?
Definitely.
Make sense? Okay, I forgot to do something, and I want to kind of go back quick and do it with you. Watch this. If you take your function f of x, okay, and then I go like this. Take this function. Come on over here. Take it and let's add 2. Tell me what to do. What do you do to the parent? What's that mean?
Up to.
Up to, that's all it means, right? So when I do this, you should be thinking, if my parent is x comma y, then my new function is x comma y plus 2, exactly. Does that make sense? And of course, if this was a minus, this would be a minus, right? Okay, let's do this one. If my function, my parent function is f of x, and then I tell you to do this, f of x minus 4. Okay, that's a right 4, you're right. Okay, but what if I look at just the ordered pairs on the parent? Then it would be what? What would you do to the parent ordered pairs? X what?
+4.
Because you said go right, it's plus 4. What do you do to the y? Don't do anything. Got it? Okay, let's do it again. If you are told this, f of x, here's your parent, okay? Do what to your parent? Let's do this. Okay. I just made your parent, I put a negative in front of it. This is a reflection where? It's, okay, yep. Okay, see that f of x? That's y. I just stuck a negative in front of y. I switched the y. This is a reflection over what? The x-axis. So if you take any point on your parent and you reflect it over your x-axis, what changes? What does it change to? Opposite. I like that you said that, Will. Opposite. Don't say negative y. Just say it turns into the opposite. Okay. Next, if you take your parent and you go like this, you're told to do this now. That's a reflection over what? That's the y-axis. So then any point on your parent, what do you do to these ordered pairs? When reflecting over y, you do what?
Negative X, or
Opposite.
You make x opposite. That's kind of the thinking that goes on in your head when you're trying to make all these transformations. Okay, so what haven't I done?
stretching.
Stretch or compress. Now, in Algebra 2, the word compression happened a lot. You heard compress, compress, compress. If you actually read your book talks about shrink. So instead of like, stretch sounds like I take the y or the x values and make them higher or longer. But compress means I make them smaller or make them come in a little bit. Okay, they don't use compress, they use the word what? Shrink. So if you hear shrink, it's compressed to you. Okay, so here we go. If I say f of x equals absolute value of x, that's your parent, and you know your parent looks like this, right? Okay, this is 2, 2. Okay, 1, 1. Okay, and I go like this. Your new function is g of x, and it is absolute value of x with a 2 in front.
Stretch it vertically.
A multiplier is your stretch factor or your compressed factor. Now, how do you know what this is? I'm hearing you guys say this. It's a stretch.
It's grade
It's
one.
grade one.
Okay, yes. So if your multiplier, your book calls your multiplier C. If your multiplier C is what? Greater than 1, it's going to stretch. And all that means, and I shouldn't say that, I should have said this. This is a vertical stretch. It makes it get taller or smaller. So that affects what? The x or the y?
Y.
It does, it affects the y. So what happens here is you go over 1 and then up 1? No. Up 2. Over 2, up 2? No. Up what? 4. So your new function is thinner. It went from this to this. It's like grab my wrist and pull me up. Okay, that's a stretch. Now, a compression would be grab my wrist and compress me back down, make me flat, okay? So, here's my question to you. If you're told this is a stretch, then the parent function, every x, y, what are you really doing to it? Multiplying what?
X to Y.
Okay, y by 2 in this case? Okay, would you guys agree with that? Is that what I did? So I took the y value, I multiplied by 2 to get what? 4. Okay, so what's going to make this thing, I'll use the book's words, shrink. Even though in my mind I say compress, but whatever.
Less than 1.
Okay,
Greater than
C
0.
has to be what?
Greater than 0, less than 1.
Greater than 0, but less than 1. Right? So give me a number.
1
Okay, let's make it easy. Let's go half. So if I have a half out here, I have half my parent. Well, if I have half my parent, now it's going to be x comma what?
Y over 2.
Half of y. So what's half of 1?
1 half.
1 half. What's half of 2?
1.
So this point comes down to here. So this would shoot out this way, correct? This is 1 half absolute value of x. This is 2 absolute value of x, right? This making sense?
Yeah.
Sometimes a nod helps.
Yeah.
Okay, thank you. All right, I think we're done. There's one more thing we're gonna do. It is coming Monday, and that is you didn't do this in Algebra 2. Unless the enriched Algebra 2 kids did it, I don't know. But there's something called, these are called vertical stretches and vertical compressions. There's also another thing called horizontal stretch and horizontal compression, shrink, whatever. Okay, that'll be Monday. So today, on today's assignment, number 12, A, B, C, D, E, F, don't do G. Because G is something you haven't seen yet, okay? All right, let's go. Grab your notes, here we go. We should be able to go pretty quick.
Mr. Kidd.
Yeah.
Can I snag a drink before we do our notes?
Or before I do my notes.
Can we just go? Can we just go?
I guess.
Yeah, thanks. I'll get you out of here, I promise. Okay, so here's what you're gonna do, but I guess we're gonna go this way. You are going to do the first slide. Ready? See if I find it. Okay. More or less, this says this. If you have, whoops. If you have your function f of x, I'll say f of x is your parent. Okay. Okay, and you are going to perform this or this, f of, open the parentheses up, x plus h or f of x minus h. Then what happens is it shifts the entire graph h units horizontally where? In the opposite direction. So if you see plus h, you're going to move your graph where? H units which way? Left. If you see minus h, move your graph right h units. Okay, so do this one right here. Okay, just kind of slide over there, make a graph. Okay, I know I didn't give you graph paper, but just do it. When you started this problem, did you know what you were looking at? What's the parent? Yeah, you guys, if you thought I was talking absolute value, you did it wrong. It says x minus 3 squared. It's a squaring function. You should be thinking this is the parent graph. So when you did it, I hope you did something like this. 0, 0, 1, 1. What's 2 get?
But don't you have to start at 3?
Yeah, but I'm just doing the parent. I'm just showing you what the parent looked like. 2, 4. Okay. Negative 1, 1, negative 2, 4. Okay, there's the parent. And then you're going to make a, what kind of shift? Shift horizontal. You said right 3? That's basically what you're doing. You just take your parent and you shift it right 3. And I would always start at a vertex. So the vertex is 0, 0. I'd go to 3. Okay, there it is. And then I would probably, if I knew what the parent did, I wouldn't even draw the parent. I just go, my vertex is 0, 0. Right 3 is 0. Now it's 3, 0. Then I just do this. Every parent goes right 1, up 1. Right 2, what? Up 4. So this is 5, this is 4. And I can see it. Left 1, up 1. Left 2, up 4. There. Okay. Now, students always ask me, do I have to draw the parent? The answer is no. But some students, I'd say, yeah, you should do it because you guys, some of you, if you see the parent, you can see it and you just go, boom, it's easy. And some of you are good enough to go, well, if I just slide the vertex over, I know what the parent does. I don't know who you are. Some of you are pretty good at this. Some of you are not so good. Do this one. This time, we're adding k to the end or subtracting k. What does adding k or subtracting k do? Up or down. And it follows the sign. Up, positive k, up. Negative k, down. Go, do it. Yeah, just graph it. Just graph it. I know I didn't give you graph paper, but just make your graph as best you can. So the plus 5 is what kind of shift? Okay, whoops, shift vertically up 5. Okay, so Where are you gonna start?
It's 5 times
0.5. You start at 0.5. You start here, and then again, if you're not gonna do the parent, you need to know what the parent does. Right 1. What?
up 1,
Up 1. You'd be at 6. Right 2.
4.
Up 4. You'd be where?
9.
9. Okay, there it is, there it is, there it is, and there you go. Okay, good. If the parent helps, draw the parent, and just lift it up 5 units. Okay, all right, keep going. There you go. Do that one. Oh, this one should be so easy because we just about did it. Is this a vertical or a horizontal shift? Horizontal shift, right? Which way?
Right.
Right forward. So the parent slides right forward. 1, 2, 3, 4, right here. Put your point and do what? I mean, I can take every point, slide it, or I can just do what the parent does. From the vertex, right 1 up 1, right 2 up 4. I just mirror it if I were you. Mirror it, and mirror this one. Oh, you can hit right here. There you go. There you go. This one is x squared. No, it isn't. Sorry, I did that wrong. It is what?
X minus 4.
Yes, it's x minus 4 squared. X minus 4, all of this squared.
You have to read the original one first.
I'm sorry, what?
Or you have to do the original one first.
No, you don't. You don't. I said if you know what your parent does, you really don't have to do this. But for some students, they just like to see it, and then it makes more sense to them. But if you're going to draw me 2 graphs, you need to label the answer. Everybody understands? This is the answer. Right here. That's the answer. Okay. All right. Next. These, I'm going to get rid of this little shade. Okay. Now, the word rigid, a rigid transformation, did I already have one of these words up here that I didn't talk about?
Rigid.
Yeah, but in the previous slides, I can't remember. No? Yeah, right here. Okay, rigid. The word rigid just basically means this. When you move your parent, rigid means that the shape is not going to change. You're going to get the same shape. And you guys, we never changed our shape. We just changed our positions, all we did. So now, when you go to this slide, it seems like this should be like, oh, now the shape's going to change. But that's not true. This is
It's not true.
oh, sorry. This is true. The shape is still not going to change. It's a what? It's a it's a reflection. So we're going to do this one right here. You are going to take the square root function. You're going to reflect it. Now, I don't want to talk about it in a second. I want you to do it. I want to see what you do. Are you reflecting over X or Y? Don't say it. Don't say it. Just do it. Okay? Oh, it does. Doggone it. You weren't supposed to see that.
I just often have
Yeah, go ahead. Go ahead. Go ahead. Sorry.
great
You guys, you should have, I said which one is it, and it was right there in front of you, but you should see that if you switch X That's like you testing for symmetry. When we did this on the test yesterday, when you switch X, you're testing for what axis? The Y. So it is symmetrical to the Y. Look at the X, it's been switched to negative X. So you should know, oh, well the parent is just this. What does the parent look like? Give me 0, 0,
Sideways.
1, 1,
Or 2.
4, 2. Okay, there it is. 9, 3, if you get that far. Okay, so when you do this one, it's a reflection over Y. So how do you reflect 0, 0? You can't. 1, 1.
Negative 1, 1.
Negative 1, 1. And by the way, when you reflect over the Y, the only thing that changes is your X value becomes opposite. So if this is 1, 1, you're now looking at negative 1, 1. Okay, so what does 4, 2 become? Negative 4, 2. Got it. There it goes. Good? Now the next one, when the negative is out in front of your function, it reflects the graph vertically over the x-axis. So this is an x-axis one. Okay. I drew the parent. This is the square root of x. Oh, it's absolute value. Didn't see it. Sorry. Okay. Okay, let's do absolute value. Absolute value. Down, up. It's a V. And of course, 1, 1, 2, 2. Okay. When the negative is in front of your function, it's going to be a reflection over what? The x-axis. Okay? So what does 0, 0 become?
0, 0.
What does 1, 1 become?
1, negative 1.
1, negative 1. 2, 2.
2, negative 2.
2, negative 2. Shoots down? Shoots down. Okay. And there they are. Okay? Good? Okay. Oh, look at the parent now. The parent is what? Cubic. This is the cubic parent. I don't think you and I have done one of these yet, so let's talk. Let's get the cubic parent on paper. Ready? 0 goes in. 0. 1 goes in. 1 times 1 times 1. 2 goes in. 8. 2, 3, 4, 5, 6, 7, 8. 2, 8. So it kind of goes like this. Really fast. What about on the other side? Negative 1. No. Negative 1 times negative 1 times negative 1.
Negative 1.
Negative 1. Negative 2 goes in. Negative 8. 2, 3, 4, 5, 6, 7, 8 right here. Okay. All right. So now you know what your parent cubic function does. It goes like this. Good. That's the parent. X cubed. You have what though?
Negative x cubed.
You took the x cubed, you went inside and changed it to negative x, which means you reflected over,
Y.
it's the y-axis. And you guys should know when you reflect over y, all you're changing is what?
X.
The x. So what's this become?
Negative 2, 8.
Negative 2, 8. Oh, I got off there a little bit. Negative 2, 8. Okay. Okay, what does this one become? Negative 1, 1. And 0, 0, when you reflect it over y, still 0, 0. This becomes 1, negative 1. This becomes
2, negative 8.
2, negative 8. Here goes. Okay, and there it goes. That's the new function right there. This is the new function. This is the parent. Okay. Do it again. This time, they did not go inside. They went on the outside function, put the negative in front. And then they did what? What did they reflect it over this? The x-axis. Okay, here's the parent. Parent's in green. 2, 3, 4, 5, 6, 7, 8.
It's the same thing.
And then 8, 2, 3, 4, 5, 6, 8. Okay, there you go. There you go. This is x cubed, right? Now we'll do the new function. Now we're reflecting over what? The x-axis. So where does this point go to 8?
8, 2.
8 to?
No,
No.
2
to
negative.
-8, right?
It's the
There.
same thing as the last one.
This one is here. 0, 0 doesn't change. This one up here. This one way up here. Okay, so I do this. And I hear you guys mumbling. It's the same thing, correct? So guys, here's the deal. You performed 2 different things and you got the same answer twice. The reason that happened, just so you know, answer this question. What's negative? Look at this one. Negative x times negative x times negative x. What is that? Negative x cubed. Okay, over here, what does this even say to you? Negative x cubed. This says negative x cubed, and when you perform this in your head, you get negative x cubed. Of course you're going to get the same picture. But did you realize you did 2 different things? You reflected over the y-axis, got this. You reflected over the x-axis, got this, the same answer. Sometimes you get the same picture doing different transformations. It's kind of weird. All right. Are you okay?
Yeah.
Okay, let's go. Use 5 points to draw a graph of this. And by the way, this is who? Parent. Okay. Then after you do it, then use that graph you just drew and a series of transformations to graph the next one. So that means multiple things are happening. Look at this one. Multiple things are happening. Just so you know this, students are always asking me, what's first? What do I do first? What do I do second? What do I do third? Well, if you guys think about the order of operations, GEMDAS, what do you always do first?
Grouping symbols.
Grouping. So guys, what's the first thing you always perform?
Move left or right.
Right.
Left or right? This is the first thing you do. Okay? The exponent means nothing with transformations. Okay, the next thing you would do is what? If you see multiplication,
Stretch.
you do it. So the second thing you do is whenever there's a multiplier out here, you either what?
Stretch and compress.
Stretch it, or you compress it. And of course that's done. You won't probably see division, so what's this?
Add and subtract.
That's the last thing you do. So that would be plus or minus, and this is up or down. This is the third thing. How do I do this? Up or down, does that make sense to you? So when you're looking at something, you go, I'll do this first, I'll do this second, and then I'll do this last. Because sometimes if you go out of order, you get the wrong answer. Sometimes you get lucky and you get the right answer. But you don't want to be lucky because if you're lucky, sometimes you're going to get it wrong. So first inside, second is the multiplier, third is the up and down movement. Okay, so what are you going to do first in this one?
Right, three.
This is right 3, then you have to look out here. Is this a stretch or a compression?
It's reflection.
Or is it neither?
It's reflection.
No. Is it stretch or compressed? Or is it neither?
Neither.
And it's neither because the number's 1. 1 won't stretch, 1 won't compress. Okay. Then you see the negative and you go, wait a second, but negative in front means
Reflection.
over what?
Accent.
Reflect over, which one?
Accent.
X. Okay, so let's go right 3. 1, 2, 3. Okay, there's my 3. Then we're going to do what? Reflect it over the
Accent.
x-axis. Well, it's just a parabola. So you have the vertex right there. Usually it's right one, up one, you're gonna go where? Down one. Usually it's right two, up four, you're gonna go down four. And then of course reflect or mirror it over. Something like this, right? Is that what you did? Yeah? Okay. Sometimes this stuff is really easy, and sometimes it's just not that easy. Okay, non-rigid, I think, hang on. It might be done here. Okay. I'm done. Okay, I'm done. The next one says do exercise 12. It's a handout. I should have given it to you yesterday. I don't know if I did. I think I did, right?
Yeah.
Okay, there you go. You were supposed to do A, B, C, D, E, F, G. Don't do G. Kyle. Don't do G. Okay. All right. You can get most of that done in 5 minutes. I'll give you your test back.
What do you mean? Oh. I was just open the what?
What are you doing? Oh, I'm sorry. Blake, getting all these wrong, Tanner. Parsons.
You want these back?
Yes, I do.
I don't know.
Morgan. There. Grace. Carly. She left. Okay. Betty.
No.
Kyle. Noah. She didn't come back,
Okay,
so I didn't grade it, but. I'll grade it. I just didn't know what was going on. Okay. Really quick, because the time's running out, just want to tell you something. If you got this grade right here, I'm just throwing a number out. Percentage-wise, somebody help me? Type it in. What is it? I know it's probably in the 70s.
75.
Wait, he said.
Okay. 75 exactly?
No. 76. Well, 70.
What's the
76.
decimal?
Point what?
Well, it's 0.755.
Okay, got it. 0.7. Okay, so now here's what I did. Just so you know, I said to myself when I was counting these wrong. Okay, that midpoint wrong. The distance point wrong. But you were showing work. And I wasn't really rewarding you enough for the work. So what I did is I went like this. I said I'm going to add 5 to this, and I'm going to add, of course, 5 to this. Okay, so this becomes your new score that goes in my book. And if you did the number crunching here, guys, it goes to that. So it's kind of weird. The worst, if you did poorly, I helped you more and more. If you did kind of average, I didn't help you much. If you got an A, guys, and you did this, I probably gave you 0.25% more. So the better you do, the less I help you. But the worse you do, the more I help you by doing this. Okay? Okay. Now, last question before you leave. We've got to talk about this. I have to be really quick here. People always say, well, I don't like my score. Can I retake it? And I say, sure you can. Couple things. I'm not going to do it tonight after school. It's Friday. But let's make a goal. By next Wednesday night, 4 o'clock, we're done doing retakes. Retakes are not free. You have to come in, and you have to sit down, and you have to work with me. I might put you to work and say, do these 5, 6, 7 problems so you get better. Then when you retake it, you don't get the real score. If you got 76 and you end up with 100 on the next test, I meet you where? In the middle. So what would be your score? What's the middle? There, that's
You
what
do
you
the
get.
first time or second time?
You can go down. You can. But you're gonna work with it. You're not.
Okay.
I need to test.
I should.
I need to test. I need to test. Good. Good. Good.
Morgan. Oh, Morgan.
Of course I need him. I need
Yes.
him last. Yes, of course.
Morgan.
Wait. Jake, I'm coming. Jake, I'm here for you, buddy. Jake, who did I not get? Okay, that's it?
Maybe your son in mine.
You're looking at the words.
That's, oh yeah, I'm sure I got C or D. Maybe I don't hold that high standards for myself.
Yes, you can. That's bad for you anyways. Oh.
So for this career thing,
Yeah, I know.
they call, you just let us know.